So in my room, how many areas would I have to calculate? Let's pretend that that ledge isn't there. Just pretend that it's flat. How many areas would I need to calculate in this room? We'll pretend that that's flat, right?
8.
How many?
8.
8. Why 8 in my room?
Because the floor is
Ceiling and floor is 2. What else?
on your wall.
And I got how many walls?
6.
I got 6 walls. I got 1, 2, 3, 4, 5, 6. So we would have to calculate 8 areas and add them all up, which is what this is. Surface area is the total area of all the surfaces in a 3D figure. Okay, each surface is a shape. You find the area of each shape and add them all together. Now, we talked yesterday a little bit about nets. Nets can be really helpful for us. If you see this, this is a box, right? And what we can do is we can unwrap that box to create a two-dimensional rendering, a two-dimensional image of the three-dimensional shape. Two-dimensional image of the three-dimensional shape. Now, what that looks like, let's see if I have it. Oh, there it is. Looks like this. If I were to take this box, right, so I'm going to fold it in, I have all these tabs so I can tape this up later. To fold it up. I'm going to make it ready and almost. I know you're excited. You're very excited, I can tell. Boom. What shape do we got? Yeah, this one's technically a square prism just because the edges, the bases are squares. But what you can do is, to make it a little bit easier for yourself, we just unwrap the top, right? Unwrap it. And you can ignore the little tabs here. And you can see that I've got how many areas? 1, 2, 3, 4, 5, 6. Because there are how many faces on this thing? There's 6. So it looks like there's 3, right? Because this is a two-dimensional picture of a 3D object, right? It's a two-dimensional picture of a 3D object, but so we know that even though we can see 3, there are actually 6, because you can't see the back, but the back is there. You can't see the bottom, but the bottom is there. We can see the top, we're good. We can see this side, but we can't see the other side. We know that they're there. So we can use nets to help us out. Nets are going to be a really useful tool for us. Okay? So let's get started. What 3D figure is this? Be specific. It's not a cube. A cube is all the exact same size. When you think cube, think dice that you roll. Think dice. Those are cubes. Okay? Is this a cube? No, it's longer than it is tall. So what is this called? It's called a rectangular prism, right? It might be helpful to sketch a net for this. Out to the right. Notice you have all that space to the right on your page. I did that on purpose. You should have lots of space to the right. Might be helpful to draw a quick net. Notice what I have labeled here. There are some labels here. This net right here has the base and the lateral faces labeled. What do you think lateral means?
Equal? It can be on either side.
Cool idea, yeah. Could be on the sides. Long, all right.
I was thinking equilateral.
You're thinking equilateral. Equilateral would mean that it has equal what?
Sides.
Well, sides. So what do you think lateral means? If these are the bases, what do you think lateral means? Well, in a prism, it's actually a little bit easier. The lateral faces are the faces that aren't the base. They're the faces that aren't the base. So this one would be the left side. Okay? This is like the left. This one right here, that's the right. How do I know? Because when I look at this, this this rectangle right here, all four of these rectangles have a length and width, right? Its width is W. Its length is H. But you notice here, W and H is right here. Thanks. So this is the right side, because there's an H right here. This is the left side. How do I know? Because for the same reason, got H, that's H, that's H, that's H. W times H is right here. It's that side. Which means if those two are the left and the right, let's use some more logic. Oops, I didn't mean to erase that part. Then what would these two be? If these two little guys are the left and the right, because it's W times H, what would these two be? Well, let's look. What face has an L and an H in it? What? The H is not the back, the H is the height. Hey guys, this is a thinking question. We haven't done any math yet because we need to be thinking. We got to try to visualize what's going on. Yep.
The L is the base and the H is the height.
Nope, the L is the length of one side and it's right here. The H is the height. So what would this, I'm looking for this shape right here in the middle. This one. Where is that one located? The back or the front. It doesn't matter which. It could be the front or the back. Because notice, H is the height. L, this is L, L. This is how this thing works. All the lateral faces here have a length, a width, and a height. Notice how the area is found by either multiplying the length of the width times the height. The bases, how are the bases found? Well, these bases are found by multiplying the length times the width, because those are this length. This is length, and then this is width. It's difficult to see as long as if we can unfold it, it makes our life a little bit easier. So here's the deal. The lateral faces mean on the sides, and I have all this stuff labeled. I want you to see, it's kind of crazy. But if you can label the length and width of every single part of your net, it will make your life a little bit easier. It will make your life a little bit easier. There's a lot of stuff labeled here. But notice height, 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 length, 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 length. And the width fills in the gaps. So lateral means on the sides. So here's what we got to do. Let's find this surface area. I've got 4 steps for you to write down. You've got space to the right of your notes to do it. Step 1, we want to break this thing up into its parts. Then step 2, we want to label each part. Now, the labels can be anything from front, back, top, bottom, left, right. Like, that's how I label things. I label things front, back, top, bottom, left, right. Or like if we're dealing with triangles, I label it like top triangle, bottom triangle, or left, right, back, those kinds of things. That's how I label things. Then we want to find the area of each part, and then finally add up all those areas. Okay? So once again, I find it helpful to think about a net for this. So you don't have to draw the net, but we are going to label this somehow. So here's what I've got. The top and bottom, I've decided for this particular problem, the top and bottom are going to be the base. So the top and bottom are going to be the base, which means that the top and the bottom are what by what? What are the dimensions of the top and bottom? Look at your page. What are the dimensions of the top and bottom? 10. Dimensions, plural, right? 10 by... Nope, 10 by 10 is not on here. There are 3 numbers. Every single face will have 2 dimensions. A length and a width, right? Or a base and a height, depending on how you like to think about it. What are the dimensions of the base? I've decided the bases are going to be the bottom, for this bottom and top for this particular shape. 10 by 3.5. Okay, 10 by 3.5. What about the lateral faces on the left and the right? What are the dimensions of those? The dimensions of the left and the right? 3.5 by 2. And what about the front and the back? What are those dimensions? 10 by 2. So let's separate those out. Let's break it into its parts. Let's do the top and bottom first. I label this top, bottom. Remember how it said label each part? I'm labeling each part. So let's do top and bottom. Notice it's kind of a long, thin rectangle, right? What are the dimensions of this one, the top and bottom? 10 by 3.5, right? So area equals base times height, or length times width. What are my base, what's my height of this particular rectangle? So notice, I'm thinking about this one rectangle now. Ignore the big shape now, right? Focus exclusively on this one rectangle. It should be pretty easy to find its area. Its area is base times height, which is 10 times 3.5, which equals 35 meters squared. But it's not 35 meters squared. It's 70 meters squared. Why?
Because
What did I just find the area of?
two.
The what? The top and bottom. So shouldn't I find its area twice? Yes, I should. This is a way to make your life a little bit more efficient. All right? And now let's draw the next one, the front and back. Let's do front and back here. Front and back. Draw that image, and we get front and back looks like this, right? A little bit skinnier. What are the dimensions of the front and the back? 2 and 10, exactly. Area equals base times height, which is 10 times 2, which is 20. But it's not 20. It's 40. So the question I have is, once again, y times 2? There's top and bottom. It's two sides. It's two sides. And then the last one, we did top, bottom, front, back, and now we need to do which one? Sides. I usually call these left and right. You can call them whatever you want, but the reason why I call them left and right, because it helps me remember that I need to do left and right, that's times 2. And this is 3.5 by 2. So area equals base times height, 3.5 times 2, which is 7. But it's not 7. Times 2 is 14 meters squared. So the final step here is do what? Add them all up, and I get 70 plus 40 plus 14 equals 124 meters squared. But why am I only adding 3 sides? This isn't 3 sides. What is this?
That 1, 2, 3, 4, 5, 6. That's 6 sides.
1, 2, 3, 4, 5, 6. If you don't want to multiply by 2, what could you do? Add 35 plus 35 plus 20 plus 20 plus 7 plus 7. That's fine. There's nothing wrong with that. Nothing wrong with that at all. Okay? If you want to recognize, hey, there's 6 sides on here, so how many sides do I need to add? 6. That's fine too. Okay? This is the longest problem we're going to do today. Okay? It's the first one. I wanted to make it intense, the first one. Questions for me on this first problem? The next one will take very little room. I tried to give a lot more space for the first one. The second one should need very little room. Questions on this first one on the steps? Yes, sir. You do not need to draw the net. The net was for me to show you to help visualize. What you need to do is you need to break the prism into its parts. You need to label each part. You need to find the area of each part, and then you need to add up all 4 of the areas, or all the areas. So yes, there will need to be some sort of labeling, because that's what it says to do, label each part. Yes? Absolutely. All right, what is this? Name this prism. What is this called? It's called a cube, exactly. What type of faces does it have? Squares, which is really helpful for us. Okay? In case you want to see what that net looks like, it looks like this. You do not have to draw it, but that's what it would look like. But what do you notice about the dimensions of all of these shapes?
They're all the same.
They're all 3 by 3. Every single one is 3 by 3. So this is the surface area only for cubes. This is the fast way. It's only for cubes. Only for cubes. Just so you know. We find the area of one of these faces, right? What is its area? 3 by 3. Base times height, which is 3 by 3, which is 9. And then what do we know? Count them up.
There's 6.
1, 2, 3, 4, 5, 6. There's 6. So 6 squares makes it so we do 9 times 6, which is 54 inches squared. So yes, for cubes, it's a lot faster, right? Let's be honest. You're only needing to find one area. Why?
Because they're all.
They're all equal.
Yeah, they're all equal areas. There are 6 faces of squares, and they're all equal. Okay? Questions on this particular problem? Notice, one thing that I have not taught you yet is how we sometimes notate inches. Notice how this looks like 3 quotes. Do you see that in there? It's tough to see, but it's 3 quotes. That quotation, a quotation means inches. A single apostrophe, do you guys know what that means? That means feet. So 2 means inches. Darius, you say feet? Yeah, a single one means feet. So a lot of times you're going to see people measured like this. Anybody ever seen something that looks sort of like that? Yeah. That's me. That's my height. 5 foot 6 inches. That's what that means. All right, last one. Here we go. Name this prism. What is this prism? Ooh, let's be careful. Why is this not a rectangular
Because
prism?
it's a triangle.
Because this is called triangular prism. Because why? The bases are triangles. What types of faces does it have? It has triangles and rectangles. Notice this is important. We want to begin by labeling the base and the faces. So this is not on your notes. This is for you to pay attention to and kind of think about. Notice here, I've got a top, a bottom, a left, right, and back for this particular shape. How many faces are there? This isn't in your notes. This is for you to watch and pay attention to and engage in. This is not in your physical notes. So how many faces are there? There are 5. If you label them, it will make your life easier. Left, right, top, bottom, and back. If you draw one of the bases, so this is a right triangular prism. Why?
Because
It's a right triangle at the base.
Yep, the bases are right triangles. How do I know that the triangles are the base? Because they are the only ones that aren't the rectangles. In a prism, the sides are always going to be rectangles. The bases are the other shape. What if they're all rectangles? Then it's a rectangular prism, it doesn't matter what the base is. But here, it does matter what the base is. Is the base a rectangle? No, because that would mean that the triangles would be its sides, and that's not true for a prism. Prisms have all rectangles for their sides. It's helpful if you draw the base and then figure the other stuff out, okay? Weird. So, here's one of the ways that you can know for a fact that this is a triangular prism. The top and the bottom, the 2 bases, they must be congruent. They're congruent and parallel. All right, so let's find the surface area of this particular one. A net may be helpful to make sure that you found that you have all the areas. It might be helpful. You have a lot more space for this one. So the net for this one, you don't have to draw it, but I'm going to show you what that net would look like. So it'll look like this. And I tried to make it so that the colors were right. How many faces are there in this triangular prism?
1, 2, 5.
There are 5. Let's find the area of the bases first. I find it's helpful to find the area of the bases first. So like how I said before, our step 1, what's our first step? Separate the parts. Okay, so we've done that where there are 5 parts. What do we do next? Label them. So we've got bases first. I'm going to draw this shape because I think it's helpful. This is a right triangle. You with me on that? Do you agree? But what numbers go on that triangle? This is where it gets a little tricky. Because it looks to me like there's only a 5 right here, right? If I look at the right rectangle, there's a right triangle, there's only a 5. But if you look elsewhere in the shape, Kobe,
There's like a 3 for the base and then a 4 on the right side.
good, so the 3 is on the left side of this shape, and that 3 can go up here as well, which means there's a 3 there. And then you said a 4 on the right side,
Yes, sir.
because there's a 4 and it can go here. A 4 there. It's going to be helpful for us, okay? But the question is, what are the base and the height of this triangle? Well, we know that the area formula for a triangle. Who remembers the area formula for a triangle?
1/2 base on height.
Thank you. A equals 1/2 base times height. So what's the base and what's the height?
3 and 4.
3 and 4. Why? Because they're perpendicular. Exactly. Great job, Des. Half of 3 times 4. What's half of 4?
2.
Times 3.
6.
So the area of this is 6 meters squared. Now notice its base is, right? So what does that mean? Why did I emphasize that? There's gonna be 2 of them. So keep that in mind. Now let's get the other faces. What other shapes are there in this figure?
Rectangles.
There's rectangles. So let's label them. Right, let's draw them. How many rectangles are there?
3.
3. So 1, 2, 3. And I know it seems silly to draw them out. I'm gonna be honest with you, it's very, very helpful. What are the dimensions of these triangles, or excuse me, of these rectangles? Well, let's label these. Let's have the left, let's have this one be the, let's call this one the right one, because I like that one first. Because that's where the 6 is, right? It's 6 by 4. That one's easy to see. You with me on that? The blue one is 6 by 4. What about the next one? What do you want to call this one? Let's call it the left. What are the dimensions of that one? 6 by 3. Well, where did that 6 go? All the heights are 6, right? All of them are 6. So might as well label them all 6, right? What do you want to call this one? I would call this one the back. Because I can't see it. Like, if I'm looking at it, I've got the right side and the left side, but then I also have the back. That's what I would call this. And it's going to be 6 by what?
5.
5. All right, so these areas should be pretty easy. 6 times 4 equals
24.
6 times 3
18.
equals 18,
30.
and 6 times 5 equals 30. Now, the final thing we have to do, what's the final thing we have to do? Yep, add 5 sides. But I only have 4 areas.
Because the bases are 2.
Exactly. For your notes, since these are notes, can we write base, base, right, left, back? We're adding them all. These are notes, so write more than what you need, right? Notes, on notes we always write more than what we need because we write so that we can easily reference what we're doing. So that way when we have a triangular prism in our homework, we can look at this and know exactly what we did. So our base is 6, our base is 6, our right side was 24, our left side was what? 18, and our back was 30. So our final answer, once we add all those together, it's 84 what? Meters squared, because it's area. So surface area problems take some time. Right, let's be honest, they take time. Especially if you're going to show your work, which you're going to have to.